For number 43, which of these tables does not represent a function? So just to get back into what the big picture of this means, something that is not a function fails the vertical line test. Well, to fail the vertical line test, it means you hit a perfectly vertical line, hits it at 2 spots or more, okay? Well, what that actually means is that these 2 points have the same x value, okay? Same x value here, same x value here. The y values are different. This could be positive, could be negative. They can both be positive, but they're going to be different. But it's the fact that they have the same x value. That's what makes them fail the vertical line test. So when something asks for us to find something that's not a function or check to see if something is a function, we're looking for unique or reused x values. So when we look through these little charts, we see the option A is all these tables represent functions. That means you can't just cop out, okay? You've got to check them. We're looking for one that reuses an x value twice. So uses an x value really more than once. That is what makes something not a function. Okay, and we get to our very first one. It uses the x value 2 one time, the point 2, 6. It uses the x value of 3 to make 3, 6 and 3, 7. That would be using the x value twice. That means B is not a function. Double check with the other ones though. 2, 6, 4, 7, 3, 8. Doesn't matter that these crisscross. What matters is they only used the x values one time each. 2, 8, 3, 7, 4, 6. This is called being a unique pairing, okay? They didn't use it more than once. They didn't use the x values more than once, okay? So that would be B. Number 44, which linear equation best represents the line of best fit for the scatter plot? So we can see that our data is trending upwards, kind of in a line that looks about like that. Not perfect, but about like that. And so we've got a bunch of options down here that we want to see which one fits our data the best. Now, if you're not confident with your equation abilities and your, y-intercept form, then you can just put all these in the calculator. But I'm pretty confident in it. So I see that we're pretty much crossing around the -1 spot. That means I'm going to get rid of this one and get rid of this one because they say we're going to cross at a y-intercept of +1 up here, which clearly we don't want to do. And then next I'm down to a slope of 1/3, which would be rise 1, run 3, which would be way over here. This would be a line that kind of looks like this. Or a slope of +3/1, which means we rise 3 and run 1. So I'm thinking that that's probably my answer. I am going to double check that one in the calculator. It is 3x -1. I said that already. -1, zoom 6. And we can see that this graph looks kind of like our data. Okay, we check the table to look at some points of it. 0, -1, yeah, that's pretty much a point on my graph. Okay, 1, 2, and 2, 5. Well, 1, 2 is on here. 2, 5 won't fit, so let's go the other direction. Okay, -1, -4, -1, -4. All 3 of these red points are pretty much a part of my data set, my scatter plot. So it seems like that equation is going to graph our data the best out of those 4 choices. Number 45, the tough part for 45 is looking past all the lines to see the data. I'm going to color some of them in to kind of help you see them a little bit better. Okay, these are all our data points. When you look past the lines and see just the dots, it makes this a little bit easier. So we can clearly tell that our data is trending downwards, okay, in between those lines. It's kind of right through this area right here. We're clearly trending downwards, okay? And whenever you start looking at the dark spots, you see that one line in particular measures our data the best. It's the closest to all these dots. You can see that A is going the wrong direction. B is trending upwards, but it comes close to a few dots up here and maybe this one, but all these data points down here are not very well represented. Okay, all these data points down here don't hit with this equation B. So A's out, B's out. C gets through some of these bottom points, but it leaves all these up here unaccounted for. So our equation that does the best job is equation D. okay? Line D. For the function shown up above, what is the range? Guys, immediately you need to just start thinking. Y values, which in this case means f of x of the function, so that's what we're looking for. We want to know these. When the domain, which means x values, just x, is this, these set of numbers. So there's two ways to go about this. Take these and plug them in to both your x's and see what the range is. The other option, and the quicker option, is to put this function in the table. This function is x squared plus 3x minus 7. Okay, so you can just plug and chug. You take the x's and plug them in, or we look at the table. So the function, the domains we're concerned with are -3. So at -3 for my x value, we should be at -7. Gets rid of this one. Also, while I'm getting rid of this one, I also notice this one only has 2 answers. So I'm thinking it's probably out 2. Probably, but let's double check. Our next domain piece was 2. At 2 right here, we are at 3. So our y, our range should have been 3. And double check our last one at 5. We should be at 33, and indeed, we're at 33. Again, you can take these and plug them in to check. 3 times 3 would be 9. 3 times -3 would be -9, -7. And these would cancel, giving us -7. So that one worked out. 2 times 2 is 4, plus 6. Okay, 4 plus 6 is 10. -7 would be 3. 5 times 5 is 25. Plus 15 would be 40. -7 would be 33. Plug and chug or put them in the table. Number 47. Okay, this requires a lot of understanding or just some very careful calculator work. Okay, so we're given the original equation, 3 raised to the x power. And I know I want to flip it. Well, to flip that, I know I need to put a negative sign out front. But then some other stuff happened. If we flipped it and only flipped it, it would be right here. Okay? But you can see it clearly got moved down. Well, moving it down makes me think we're probably going to need some number plus minus out here. And it looks like they only moved it down 1. Okay? So we flipped it, we moved it down 1. Down 1 actually just means -1. And then you can tell by looking at your answers, we also shifted it either up or down 2. So really, our options are this. Plus or minus 2 up top, plus or minus 1 out back. So we're gonna go ahead and sort through some of those. I hop in my graph and I want to graph one of these equations. I'm going to start with the ones that have -1 on the back because I'm thinking it goes down 1. So let's try that first. We've got -3 raised to the x power -2. So really my prior knowledge really just helps me kind of start out and maybe go through these a little bit quicker. We can see this clearly does not match our black graph that we have over here. This one goes through at -1. We don't want it to do that. Sorry, my graph kind of makes it look like we do. We don't want ours to go through -1. We need to have this point -2, -2. That's my checkpoint there. So A didn't work out. But it kind of did some of the stuff I thought it would. It shifted it down 1. Okay, it didn't just flip it right here on the line. It shifted it down 1. So I'm going to try the other one that had a downshift of 1. And I'm not going to retype it all in. I can see the only thing that changed is the plus sign right there. And then I'm going to graph this. Now this looks like our graph over here. This looks like the graph on the question. Let's just double check that it has this point -2, -2 by looking in the table. And we can see that indeed we have the point -2, -2. Therefore, this would be our answer. Number 48, again, which order does not represent a function? Okay? Does not represent a function means we used an x value more than once. So to fail the vertical line test, we have to use an x value more than once. So let's check them. 0, 2, 4, -2, 5. We didn't use an x value more than once. Just because it was 2 and -2, those are different x values. 0, 2, 4, another plain 2, 5, 7. I'm thinking B is the answer. Let's double check. -3, 2, 0, 1, 4, 5. All those are unique.